Let's get the graph of the function f of x equal x to the third over x squared minus 1. Let's start by factor the denominator. This is the difference of 2 squared, so we get x minus 1 times x plus 1. The numerator is x to the third. So this tells us the domain of the function is from negative infinity to negative 1, union negative 1 to 1, union 1 to infinity. The x-intercept, let f of x equal to 0. This means x to the third equal to 0. So x equal to 0. Y-intercept, let y equal to 0. Let x equal to 0. So f of 0 is equal 0. So here the x-intercept is 0, 0, and y-intercept is also 0, 0. Talk about the end behavior. Take a look at the limit at x approaches infinity of x to the third divided by x squared minus 1. Note that the degree of the numerator is larger than the degree of the denominator. So in order to take this limit, I need to break up x to the third divided by x squared minus 1 into two smaller polynomial or rational expression. Okay, so to do that, I perform long division. So x squared minus 1 into x to the third. So that x to the third minus x. So subtract. Let's get to 0. And now we have a positive x. So then x to the third divided by x squared minus 1 is the same as saying x plus x divided by x squared minus 1. So now I have the limit at x approaches infinity of x plus x divided by x squared minus 1. Use the limit law. I have limit at x approaches infinity of x plus the limit at x approaches infinity of x over x squared minus 1. So the limit at x approaches infinity of x divided by x squared minus 1 equal to 0. So here I have x. Oh, infinity. Okay. Then in the next case, the limit at x approaches negative infinity of x to the third divided by x squared minus 1. This again is the limit at x approaches negative infinity of x plus the limit at x approaches negative infinity of x divided by x squared minus 1. Again, this equal to negative infinity. Now recall we did the long division because the degree of the numerator is greater than the degree of the denominator, and we got this portion at x, right? So this is our slant asymptote. So here we have f of x have the slant asymptote of y equal x. And here we have a vertical asymptote. X equal negative 1 and x equal 1. So now that we have the vertical asymptote and the slant asymptote, let's go ahead and put it onto our graph. Vertical asymptote at -1 and 1. The slant asymptote is y equal x. And we have the x and y intercept. Okay, we'll leave it here for a minute. We'll come back to it later. Now the next thing is to find a critical point. Let's start by finding the derivative of f of x. So we have x squared minus 1 times 3x squared minus x to the third times 2x divided by x squared minus 1 squared. This simplifies to x to the fourth minus 3x squared divided by x squared minus 1 squared. At prime of x equal to 0, this means x to the fourth minus 3x squared equal to 0. Factor out x squared minus 3 equal to 0. This means x equals 0, x equal to 3, and that is about 1.73, and x equal negative root 3, that is about negative 1.73. Now that we have the critical value, we'll use that to find the increasing and decreasing interval of this graph. So we take a look at the interval. We divide the interval into negative infinity to negative 1.73, negative 1.73 to negative 1, negative 1 to 1, 1 to 1.73, and the last interval 1.73 to infinity. We use test value, and here we have our f of x. So x squared minus 3, the denominator x squared minus 1 squared, and overall f prime of x. We use test value x equal negative 3, x equal negative 1.5, x equal 0.5, x equal 1.5, and x equal 3. So we have positive, 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 and positive, which means f of x is increasing in this interval. Positive, negative, positive, so negative, and we have a decreasing. Again, decreasing. Again, decreasing. And increasing. This means here we have a max at x equal to negative 1.73, y equal f of negative 1.73, and the local max is at negative 2.60. We have a local min at x equal 1.73, and y is f of 1.73, that equal 2.60 approximately. So we have a max and we have a min. The next thing we do, the last step, is to find the concavity. To find the concavity, I take the second derivative. So f double prime of x. is equal to derivative of the denominator. That's a chain rule. Note that there's an x squared minus 1 squared in the first term in the numerator and an x squared minus 1 in the second term of the numerator. I'll go ahead and factor out x squared minus 1 in the numerator. Then simplify that with the denominator. I left with x squared minus 1 times 4x to the third minus 6x minus 4x times x to the 4 minus 3x squared divided by x squared minus 1 to the third. Expand the numerator, combine like term, we get 2x to the third plus 6x divided by x squared minus 1 to the third. So f double prime of x equal to 0. This means 2x to the third plus 6x equal to 0. So then we factor out 2x. We left with x squared minus 3 plus 3 equal to 0. So x equal to 0. Now let's take a look at the table. We'll make this second derivative test for concavity. We divide this into the interval from negative infinity to negative 1, negative 1 to 0, 0 to 1, from 1 to positive infinity. Again, we use test value. The numerator, we get 2x, x squared plus 3. The denominator, x squared minus 1 to the third. So f double prime of x. We use test value, x equal negative 2, x equal negative 0.5, x equal 0.5, and x equal 2. So here we got negative, positive, positive. So here we get a negative, which means the graph is concave down. Negative, positive, negative, positive. So now we have a concave up. Positive, positive, negative. So then negative, we have a concave down. Positive, positive, positive. So this is positive, and now we have a concave up. This means we have an inflection point at x equal to 0, and y is f of 0 equal to 0. Now let's put all that information onto our graph. Let's go back to the graph. Now we know that from negative infinity to positive 1, we have an increase, negative infinity to negative 1.73. So let's see where negative 1.73 is. So let's plot that. So negative 1.73, negative 2.60, so that's our max. So let's plot that. Okay, so that's our local max. And we have a local min at x equal 1.73 and y equal 2.6. Okay. The graph is concave, and we were told that the graph is concave down from negative infinity to negative 1. So this is what our graph would look like. Yeah. We have a concave down from negative 1 to 0, the inflection point, then concave up. And the last bit of our graph.